start off with extrema and accumulation. This is combining the accumulation stuff that we've been doing with the graph analysis work. So the rate of change of the volume of water in a tank is given by V prime of t equals negative t squared plus 6t minus 8 in gallons per minute. There are 250 gallons in the tank to begin with. For our first problem, what is the minimum amount of water in the tank from 0 to 6 minutes? Okay, so we are interested in a minimum. So amount, that's by amount, we're really talking about volume here. So this is V of t from 0 to 6. Minimum comes from the increasing, decreasing line. And we're told about V prime of t, and also because we're using an equation, we have to have a plus minus line. And that lines up with V prime of t from 0 to 6. So now we need to take our V prime of t and use it to do our graph analysis just like we normally would. V prime of t is negative t squared plus 6t minus 8. If we do our factoring, so that would be t and negative t. And to get negative 8, we can do 4 and negative 2, and that works out fine. 2t plus 4t gives us that 6t right here. So V prime of t is negative t plus 4 times t minus 2. If you factored it differently as negative t plus 2 and then t minus 4, you'll get the same thing. Basically, you could factor out a negative 1 here, and you would have negative times t minus 4 times t minus 2. So if you distribute the negative to the other one, that's fine. So we'll find our zeros. Negative t plus 4 equals 0. 4 equals t. T minus 2 equals 0. T equals 2. And now if we pick our test points, number between 0 and 2 is 1. Negative 1 plus 4 is positive. Negative 1 minus 2 is negative. Between 2 and 4, 3. Negative 3 plus 4 is positive. 3 minus 2 is positive. And then 5. Negative 5 plus 4 is negative. 5 minus 2 is positive. So that means over here, decreasing, increasing, decreasing. We have potential minima at t equals 2 and t equals 6. So we need to find V of 2 and V of 6 and compare them. We know that how much water is in the tank at t equals 2 is going to be the initial amount plus the integral from 0 to 2 of V prime of t. We know that initial amount was 250 gallons. And then if we just plop this in the calculator, remember v prime of t is negative t squared plus 6t minus 8. We're going to get negative 6.6 repeating, or v of 2 equals 243.3 repeating gallons. Okay, so let's compare that to v of 6. This is the initial amount, 2. But now we're going to add the integral from 0 to 6 of v prime of t dt. And again, if we put that in the calculator, use finite integral, we get negative 12. This is smaller. So this means the minimum amount in the tank from 0 to 6 is 238 gallons at time t equals 6. We can also be asked something like this. What is the average rate of change of the volume of water during the time that volume is increasing? Well, from our work up here, we already have the v of t chart. I'm just going to copy it below for reference. We can see that v of t is increasing from t equals 2 to t equals 4. So that means that we're going to find the integral when the volume is increasing, so that's from 2 to 4, of v prime of t dt. We're looking for average rate of change, so we have to divide by that bound minus that bound. That's our average value of v prime of t. So this is 1/2 integral from 2 to 4 of negative t squared plus 6t minus 8. And if we put that into the calculator, that's 1/2 times 1.3 repeating, which equals 0.6 repeating gallons per minute. It's the same units that we had for v prime of t originally. Wheat is being poured into a grain silo. And a grain silo is basically just like this big building with no windows that you basically just dump wheat in, or any other sort of grain before it's processed. And it's being dumped at a rate W of t equals t squared for T is between 0 and 12 minutes. And let's say this is in cubic meters per minute. On the same time interval, wheat is being removed from the silo. At a rate in cubic meters per minute of Q of T is 12 minus T. So let's start off. What is the overall rate of change? Let's call that C of T of the volume of the wheat in the silo. So what we're looking at is we've got some wheat that's being poured in, we've got some wheat that's being taken out. Overall, how quickly is it changing? So obviously the level's going up because there's stuff being poured in, and the level's going down because there's stuff being taken out. How do these balance each other out? So what we're really saying is we're saying that C of T, so the overall rate of change, is the rate in minus the rate out. And we've seen that before. So C of T is T squared minus 12 minus T, so C of T, T squared, subtracting a negative is a positive, T squared plus T minus 12. And that's still going to be in meters cubed per minute. So once we have that, we can ask all of our normal questions. When is the rate of change of the volume at a minimum? Okay, so rate of change of the volume. We were just asked what's the overall rate of change of the volume, C of T. So rate of change of the volume is C of T. This means find minimum for C of T. So we're going to start with our C of T line. And this is going to start at 0 because time can't be negative. And we want the increasing, decreasing line. So that means we have to take the derivative, and we want the plus minus line, just like usual. So if C of T is T squared plus T minus 12, C prime of T is 2T plus 1. So 0 equals 2T plus 1. Negative 1, 2T. T equals negative 1/2. And let's see, this was on the interval 0 to 12, right? So negative 1/2 would be over here. It never occurs because we can't have a negative time. So that means that this whole interval is just one big thing. So if t is bigger than 0, so let's say t is 1, so 2 times 1 plus 1, that's going to be a positive. So C prime of t is always positive, so C of t is always increasing. That means the minimum occurs at t equals 0. We don't have to check any other points, that's the only one. So because we're asked for when is the rate of change volume of avogadro minimum, because we're asked for when, this is all that we need. And just make sure to have the units. That is minutes. If we had 2, then we would need to plug in and figure out what's the actual value of C of t when t is 0, what's the actual value of C of t at some other number, etc., 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 just like we've done for finding absolute minimum and maximum in the past. But for now, that's all we need to do. We can ask a different question, though, which is, what is the minimum amount of wheat in the silo if there are originally 500 cubic meters of wheat. So notice we're being asked for something different. This is not the minimum rate of change like we were asked up here. This is the minimum amount of wheat. So the minimum amount of wheat, amount is the antiderivative of the rate. So this is the antiderivative of C of t. So amount of wheat, the antiderivative of C of t. And again, 0 to 12. So that means the derivative is just plain old C of t. Okay. And C of t is t squared plus t minus 12. So that is t plus 4, t minus 3. So t plus 4 equals 0, t equals negative 4. We're not going to use that because we have to go between 0 and 12. T minus 3 equals 0, t equals 3. So we're going to put 3 on the line. Notice if this was not something that we could actually factor, we could just use our graphing calculator, graph it, and find the zeros. But whatever way works, the tricky thing about here is figuring out what the question's asking for. The mechanics of it are all things we've done in the past. So between 0 and 3, let's see, positive, negative, negative overall, positive, positive, positive overall, decreasing, increasing. So again, the minimum amount of wheat occurs at 3, but we want to know the actual amount, not just when it occurs. So minimum is going to be the amount. So let's call the amount of wheat. Let's see, W of t has already been used, Q of t. Let's call this A of t. So we have something to label it. So the minimum is going to be A of 3, and that is the starting amount plus the integral of its derivative from 0 to 3. Its derivative is C of t. And we're told that there are originally 500 cubic meters. Then we can just grab our calculator. This is one that we could do by hand, but if we have a calculator, might as well use it. So x squared, or variable squared, plus variable minus 12, comma, variable, comma, 0, comma, 3. Minus 22.5. So this is going to give us, the minimum amount is 477.5 cubic meters.